ASRock is an anti-submarine rocket. ASRock is an integrated weapon system. ASRock is a surface-to-underwater weapon for cruiser and destroyer type ships. It is primarily designed for use against high-speed enemy submarines. This film will introduce you to the ASRock weapon system. The ASRock fire control equipment is located in the ASW control room. The system obtains target data from an AN SQS-23 or 26 sonar located close by. The ASRock launcher is usually amidships. Launcher operation is monitored from the launcher control station. On the bridge, a position indicator displays, for the commanding officer, information on the progress of the attack and other essential data. Two different ASRock weapons are available. The torpedo can be used against targets from a minimum range of 1,000 yards to a maximum range of 10,000 yards. The Mark 44 torpedo has an active acoustic homing system. Its homing ranges are reliable range 600 yards, maximum range 1,000 yards. The torpedo is effective against targets at depths of 50 to 1,000 feet. Operational tests have indicated that the torpedo is effective against fast attack submarines. The other weapon is a depth charge containing a nuclear warhead. Target ranges for using this nuclear weapon are 3,500 to 10,000 yards. The depth charge is effective against the higher speed nuclear submarines. Other tactical information concerning this nuclear weapon is available from secret publications. 8 ASRock weapons are carried aboard ship in the launcher. Most ships can carry up to 9 additional weapons stowed in magazines. The time between firings is about 17 seconds for missiles from the same guide and 27 seconds for missiles from different guides. ASRock missiles can be loaded while in port or underway. In preparation for loading, a check of the launcher is first made. A missile electrical system test set, usually called the MEST, is used for this purpose. The check is essential to ensure that electrical connections will not cause premature firing when a missile is loaded into the launcher. The MEST set can reveal whether any stray voltages exist in the launcher circuits. By running through a simulated firing sequence, the set can also show whether proper signals will be relayed to the missile at the time of firing. To do this, the safe fire switch on the guide must first be positioned to fire. Inside the launcher control station, the launcher captain sets up the proper controls to send standby and firing signals to the launcher. The MEST shows that the missiles will respond correctly. A safety precaution unique to the ASRock system is this. The safety plug should always be in possession of the officer in charge of missile loading to prevent accidental firing while the operation is in progress. Another precaution, the power drive selector must be left in local position to ensure that signals from the attack console will not move the launcher during loading. Whether loading in port or at sea, the safety precautions must be strictly adhered to. Each missile is transported separately in a reusable container. A shorting plug placed in the missile during storage and shipment must be removed before the missile is put into the guide. It is replaced with an umbilical cable which permits electrical functions to be transmitted to the missile for monitoring in the cell. When the missile is in position in the launcher, snubbers will be activated to hold it securely until the time of firing. Looking at an empty launcher rail, we can see the snubbers move to latch the missile in place. When the missile is properly positioned, the snubbing and latching is effected from the launcher captain's control panel. For shipping, a thrust neutralizer is installed on the missile to prevent the missile from taking off in case the rocket motor should become ignited. The thrust neutralizer must be removed when the missile is loaded. Failure to remove it would cause the missile to remain in the launcher at the time of firing. About 50 minutes is required for underway transfer and loading of 8 ASRock missiles. The ASRock weapon system has been designed to provide extensive training capabilities, whether the ship is in port or underway. A full attack can be simulated, including all steps in the firing sequence. We'll watch a training exercise to see how it is handled. When not working with a real submarine, the role of the target ship can be played by the sonar target simulator. A realistic audio and visual target presentation from the simulator is received by the sonar. Smooth target tracking is essential since sonar data is fed to a computer for solution of the fire control problem. If sonar loses the target, information can be fed in from the ASRock system to aid reacquiring. Own ship and target data are received by the attack console, the central unit of the system. Equipment located in the console includes the computer and memory drum. In the original ASRock Fire Control Group, Mark 111, a digital computer is used. A later version, the Mark 114, uses an analog computer and does not have a memory drum. The attack console unit operator is the senior member of the attack console team. He sets in assumed target depth in accordance with doctrine. Dials on his console show the solution for true wind direction and speed. To assist the computer in obtaining an initial solution, the attack control unit operator can enter his own estimate of target course and speed. Meanwhile, the weapon control unit operator checks to see that each missile is ready for firing. This is necessary because the simulator can set in various payload and system malfunctions. The weapons control unit display will show whether each launcher rail is equipped with a torpedo, a depth charge, or a dud, or altogether empty. It also shows which rail has been selected. The operator has already set in the value of air density as computed in advance by the sonar officer. He will set in values for pattern angle and pattern radius as indicated by doctrine, by type of ship, or for pattern firings. The geographic plotter provides a picture of the attack problem. It shows own ship position, target track and position, and computed missile water entry point. The operator monitors the computer solution and the progress of the attack. Accuracy of the computer solution is indicated by these numbers. The higher the number lighted, the more accurate the solution. The weapon control unit operator, on order, selects a depth charge or a torpedo for firing. For a torpedo, he also sets the initial search depth and floor depth of torpedo search. These are ordered by the sonar officer based on doctrine, the tactical situation, and bathothermograph readings, usually referred to as BT. The firing status display shows whether the missile is ready for firing, whether the solution indicates the target is safely beyond minimum range from own ship, whether commanding officer has given permission to fire, whether launcher is ready, whether the launcher is clear of own ship superstructure, and whether certain last-minute functions are properly carried out just before firing. For the solution of the fire control problem, the attack console receives own ship course and speed, and roll and pitch, target range and bearing, air density set in manually, and relative wind. Based on this information, the console computes target movement and missile water entry point, taking into account wind, air density, and missile ballistic data. It also computes data to control the missile flight, rocket motor cutoff velocity, and airframe separation time, and sends these values to a relay transmitter located in the launcher control station. On order, the launcher captain matches up and shifts to remote. From his position, he can make sure that the area is clear of personnel and that the launcher is functioning properly. By shifting to local control, he can operate the launcher and, if necessary, fire. Also in the launcher control station is the launcher and missile simulator. During training, the simulator receives the missile and launcher signals and sends back appropriate responses. In addition, the instructor can select one or more system malfunctions to test responses of the crew. If the torpedo defective malfunction has been set in, and the operator selects the cell containing the defective torpedo, the missile not ready light stays on. However, when the operator responds correctly by selecting another cell with a functioning torpedo, missile not ready is replaced with the missile ready light. Target tracking continues until the target is within firing range and a good solution has been obtained. On order, the weapon control unit operator shifts the firing switch to standby, then to fire, thus starting the final chain of events leading up to missile firing. The simulated firing completes this training run. The system can be reset easily for another training exercise. You have seen how the ASRock system is handled for training. The procedures for actual firing are all the same, but some additional steps must be taken. In advance, the launcher captain unlocks the safe fire switch and sets it to fire. On each depth charge to be fired, he performs two additional actions. He inserts the Mark 112 power supply. This power supply provides energy for initiating detonation of the nuclear warhead. Through a port on the opposite side of the guide, he sets the depth charge arm safe switch to arm. Each of these steps is associated with extensive safety precautions taken to prevent inadvertent or unauthorized firing.
Sonar contact bearing 075, range 2,600 yards. Classified possible submarine.
The decision to fire a depth charge or a torpedo rests with the commanding officer and is based on the tactical situation and nearness of friendly ships and aircraft.
The bearing is clear. This will be a torpedo attack.
In the ASW room, the sonar officer supervises the actions of the sonar and attack console operators.
Select cell 2. ISD 50. Floor 250. Launcher control, match up, and shift to remote.
The position indicator provides the commanding officer with the information he needs to follow the attack and to ensure own ship safety. It shows him target angle, target range, target bearing, launcher train, and own ship course. Scribe marks on this dial show safe and unsafe firing sectors. It also shows water entry point, bearing, and range. If the water entry point, range, and firing bearing are within safe limits, the captain gives permission to fire. Interlocks prevent firing until this permission has been given.
Torpedo approved. Torpedo approved. Insert safety plug. Insert safety plug.
Launcher aye. Safety plug inserted.
Stand by. All stations control, stand by.
On certain ships, fire control radar is capable of tracking the missile in flight and displaying the water entry point on the geographic plotter. The missile reaches motor cutoff velocity. The motor separates and falls away. This preset velocity value determines missile range. At the preset separation time, the airframe separates. A parachute opens to slow the torpedo for water entry. The nose cone shatters and the parachute is released. The torpedo dives to the initial search depth and begins active searching. If it has not located the target by the time it reaches the preset floor depth, it starts up again, still searching. When it locates the target, the torpedo homes in on it. The procedures for firing a depth charge are the same. However, consideration must be given to safety of own ship from the underwater nuclear burst. No parachute is used with the depth charge. It drops through the water until it reaches proper depth. Then, ASRock, with its rocket motor and choice of warheads, provides an effective weapon against the extended capabilities of modern submarines.